Hi, my name is Graham Brown, and I'm a student in the Business Intelligence and Analytics program at Nova Scotia Community College, set to graduate this May of 2022. This is a brief video to outline one of my final projects. In this case, I decided to use a public data source to demonstrate importing, modeling, and visualizing some data. I was looking for a data set with quite a bit of dimensionality, and while something with a lot of records would be nice, just to demonstrate working with a larger set, it wasn't a requirement. In my case, my subject has both. I chose to work with data provided by the Government of Canada's Open Data Portal. The data comes from Transport Canada's National Collision Database. At the time of this report, the data was only available for 2019, but it is indeed quite a rich set. I'm going to show you how I went from this, a CSV file, to this, an interactive dashboard. After accessing the file as a CSV, I imported it into Excel using the Power Query functionality to understand and create the dimension tables. The data was coded and came with a good data dictionary, so I got to work using Excel so I could create numeric lookups and provide descriptions for the coded data. I needed to create lookup tables because many of the dimensions were mostly numeric, but also contained some letters, so we had integer and string values together in the same columns. Once that exercise was done, I loaded the dimensions into Power BI as queries. I got to work modeling the data in Power BI first. There are two ways to create relationships in Power BI, but both do the same thing. I chose to create the relationships in diagram view for my own clarity, since there are a lot of dimensions. I will show you some of these now. I created my own calendar table, which is capable of being carried into the future, because the most recent available date in the calendar will automatically update to whatever date it is when the user is accessing the model. Here you can see some of the other dimensions as queries. Now onto the diagram view. Here are the relationships. This model reflects a star schema where each dimension that I created earlier, or each dimension table I should say, has an ID that links it to the master table, and you can see how they are all related. Now, back to the dashboard I previewed earlier. Now that the data is modeled, we can view the end product. This is an interactive dashboard that displays different levels of analysis of the collision data. At the top left are two cards which show the most summary level statistics. As you'll see later, these aren't just text boxes. They are linked to the data set and will reflect changes when slicing and filtering. We also have a table showing collisions by weather conditions, and a bar chart showing collisions by accident type. For example, rear-end collision, head-on collision, right-angle collisions, things like that. Toward the top right, there's a table of collisions by vehicle type, and below that are three line charts showing aggregates for the year 2019 of collisions by day of week, collisions by month of year, and collisions by time of day. There's also a slicer toward the top to show all the data based on whether the collisions involved a fatality, an injury, or no injury. I also included the not applicable and unknown categories to preserve the integrity of the data set. You can see, for example, if I select a point on collisions by day of the week, all the data will change to reflect that day of the week. Or I could say, I want to see collision numbers for when it's raining only. I could select that in my table and it will dynamically update. If I want to go back to the default state with no filtering, I can simply click it again. The slicers can be useful to sort between fatal and non-fatal collisions. For example, the most common type of collision by far is rear-end collision. However, if we look at fatalities only, you can observe that head-on collisions are the most common. Upon reflection, this is not surprising, just given the nature and speed of those type of collisions. Second type is any other single vehicle collision. This could be a car that hit a tree, object, building, or something like that. It could even be a car that hit a pedestrian, and in fact the pedestrian was the person who was killed. Because there are so many interactions, one could kind of get lost and it might not be clear what is filtering on what. So I included a Clear All Filters button toward the top to reset to the default state. Now we can look at some questions. What time of day do most accidents happen? Well, the chart shows that in aggregate, collisions tend to peak during hours you might associate with rush hour traffic at the end of the workday. That's not too surprising. There's a lot of cars on the road, and perhaps maybe people are tired out from a hard day of work. What about the day of the week? While I can't explain why Tuesday peaks so highly, like our previous question, it is not surprising that most collisions happen during the weekdays, when most business is conducted and most people are traveling to or from work. How about months of the year? One might expect there to be more accidents in the winter season when things are more likely to be slippery. While they are high in January, the collisions decline until the warmer months approach and they start to rise again. Could it be that less people are on the road in the middle of winter when conditions are likely to be worse? And conversely, are people more likely to be on the road when conditions are nice? For example, I had originally thought there would be fewer collisions during clear and sunny conditions. However, we have to remember that at this time, we're unable to analyze against overall traffic flows. So while assumptions aren't so helpful, we may assume that there are just way more vehicles on the road when conditions are nicer. One thing that is interesting to note, and this is something I observed only after analyzing the data, and I don't pretend to have an explanation for it, but there is a close to even split between male and female operators when analyzing all collisions. However, when we look at only collisions where a fatality occurred, male operators have a much higher share, almost 70%. I do not have a further point to make on this, but it is something that showed up when analyzing the data. So what conclusions can we draw from this? Well, scientifically speaking, probably not many. Analyzing many years of data together would allow us to see if at least 2019 was typical of overall collisions through time, and also having other years would allow us to get a more robust sample. We also should hesitate to draw too many serious conclusions without being able to compare the incident numbers against overall vehicle traffic patterns. One conclusion we should draw from this is that modeling and visualizing data is a lot of fun, and it's worth it to put in the legwork to model your data and enjoy the usability of Power BI or applications like it. Thank you very much for watching.